Okay, let's unpack this. How do you keep tabs on every single tiny tweak happening in your cloud? Knowing every change is logged, every setting is compliant, without, well, losing your mind. Today, we're diving into AWS Config. It really does act like your ultimate digital detective for cloud resources.
Yeah, it's fascinating because in today's super dynamic cloud world, this kind of continuous monitoring, it isn't just nice to have anymore.
Right.
It's absolutely fundamental for control, for governance. AWS Config gives you that critical, sort of immutable timeline.
Immutable, yeah. Auditable.
Exactly. Essential for security. And it really cuts down investigation time if something, goes wrong. It moves you from guesswork to certainty.
Certainty. That's a powerful idea. So, okay, if config is our detective, how does it actually gather its evidence? What exactly are these configuration items we keep hearing about? Like, are they the digital fingerprints?
They absolutely are the fingerprints. That's a great way to put it. They're the fundamental building blocks of config. So each configuration item, or CI, it's basically a detailed JSON record. It captures the entire state of an AWS resource. Think an EC2 instance, maybe an S3 bucket, a database at one specific point in time.
The whole state.
The whole state. Its type, ID, tags, all the configuration attributes like, say, the instance size or S3 bucket permissions. And crucially, its relationships to other resources.
Relationships, too, like what security groups it uses.
Exactly like that. And these CIs, they get generated automatically whenever a resource is created or modified or even deleted. It's often triggered by API calls that AWS CloudTrail tracks. That's the logging service.
Oh, CloudTrail integration. Makes sense.
Right. And all these CIs, they get stored securely in an S3 bucket you designate. That builds up this incredibly rich, historical, auditable timeline of your whole environment.
So it's like an unblinking eye, just constantly recording. So even if a resource is, I don't know, accidentally misconfigured for just a minute, config captures that specific state for an audit later.
TC, that's invaluable, right?
Totally invaluable.
Yeah.
But okay, it's one thing to know what's configured. It's another to know if that configuration is right. How does config actually bridge that gap? How does it check for compliance?
Yeah. This is where the detective starts its real analysis, making those CIs actionable. AWS Config uses rules. Predefined rules.
Rules?
They can pick from, I think it's over 150 AWS managed rules now. They cover common security best practices, operational stuff, compliance standards.
Like checking for public S3 bucket.
Exactly. S3 bucket public read prohibited is a classic example. Or, and this is powerful, you can define your own custom rules using AWS Lambda functions, the serverless compute service for your really specific needs.
Custom rules too. Okay.
And config just continuously evaluates your resource CIs against these rules, managed or custom. It flags them, compliant or non-compliant, and it gives you the details on why something failed to check.
And this is where it gets really interesting for me, the automation part. Automated remediation, fixing things automatically. It sounds amazing for compliance. But like, how do teams make sure these auto fixes don't break something important, cause, unintended consequences?
That's a really critical point, and it highlights why you need a measured approach, definitely. The truly powerful part is that you can configure automated remediation, often using Lambda again, or AWS Systems Manager automation documents. Those are like predefined workflows.
Okay, SSM docs.
Right. And this shifts your whole posture from reactive, putting out fires, to proactive, self-healing infrastructure, essentially.
Self-healing, wow.
So, like, if a public S3 bucket gets detected, config could trigger an action to automatically slap on a policy restricting public access. But to your point about safety, you absolutely have to test these actions thoroughly. Non-production environments first.
Test.
Absolutely. Start with maybe less critical rules, understand the impact, then roll out more broadly. That way you get the continuous enforcement you want, but with controlled, tested automation.
That proactive bit feels like a huge step up. Okay, so thinking about the listener, what does this mean for you if you're wanting to get started with this? How do you become this detective in your own cloud without just getting completely snowed under by all the CIs and rules?
Yeah, it can seem like a lot. The key is start simple. Seriously, enable config maybe just in one region to begin with.
Just one region, okay?
Track just a few key resource types. The ones that matter most immediately, S3 buckets, maybe EC2 instances, critical IAM roles perhaps. Then try out just a couple of managed rules. Get some quick wins.
Like that MFA one you mentioned.
Exactly. IAM user, no MFA enabled. It's straightforward, high value. Flags users without multi-factor authentication. Easy win. Also, keep an eye on cost.
Ah, yes, cost. Good point.
Config charges per recording, per rule evaluation. You can monitor it easily in the AWS billing dashboard, but just be mindful as you scale up. And, super important, security. Use strong IAM policies to control who can access config data, and definitely enable S3 bucket encryption for where those CIs are stored.
Protect the evidence.
Protect the evidence.
Yeah.
And yeah, there might be a slight delay, maybe a few minutes between a change happening and config recording it, but that comprehensive history it builds, it far outweighs that tiny lag.
What an incredible tool. Just for gaining clarity, getting that control over your cloud.
Yeah.
It really feels like a shortcut to being genuinely informed about your security, your compliance.
Yeah.
Gives you that peace of mind, you know?
It really does. And maybe consider this as a final thought. If you could instantly see the entire history, every change, who made it, when, for every single resource, how might that fundamentally change how you approach not just security and operations, but maybe even how you design your future cloud architecture?